Hello and welcome back, guys. Thanks for joining me. This is Coach Williams or Mr. Williams. We're going to run through the practice problems from section 32.2. This will be one of the longer videos, FYI, in this section, because we're going to go through the practice problems, and then I am actually going to work some of 32.3 with you. So let's go through the practice problems first. Question number 7 talks about what would the central angle be, or how would you find the central angle for a circle that's divided into 6 equal sectors. So you would just do 360 over 6, so you get 60 degrees. Hopefully that's pretty straightforward. Number 8, what do they call it when you add up all the arcs of all the arc lengths of a circle? That would just be the circumference. Number 9, they want you to differentiate between an arc measure versus an arc length. Arc measure is talking about the degrees. Arc length would be in feet or miles or whatever. So there are differences there. Number 10. They have arc length. The formula for that is 2 pi r theta over 360. And so we simply plug in, our radius is 5, so we get 10 pi theta over 360 equals 1.25 pi. They give us the arc length. Then you do some math there and you'll get the angle is equal to 45 degrees. Number 11, sector area, we use the formula and then we plug in the values they give us. They give us that the radius is 5, so the radius squared would be 25. The degrees is 36 degrees and it's over 360. You do the math and reduce that, 36 over 360, you get a 10 down here, 25 over 10 reduces to 5 over 2. Okay, so hopefully you're good with that. If you want to match up your decimal answer, you're welcome to put that in the calculator. Number 12, 3.2 pi equals 2 pi 8. 8 is the radius, and then theta. We keep using theta for that unknown angle. Remember, it's just like an x, all right? Over 360, so you got 3.2, multiply by 360, and then we divide by the 2 times the 8. Notice the pi's canceled. One thing that happens here a lot of times is when you set these equal to each other, and it happened here as well, this pi would cancel with this pi. Same thing over here, the 3.2 pi and the 2, like because there's a pi on both sides, you could divide by pi and that would just disappear. All right, that's gonna happen a lot. So you get 72 degrees. Number 13, I wanted to show you the work for it. So just to make sure we're clear, 60 over 360, this is going to reduce, this is going to go away, this is going to become a 6. We're going to multiply both sides by 6, and so we're going to get 36 pi equals pi r squared. The pi's cancel, and then 36 equals r squared, so r is just equal to 6. Hopefully that makes sense. Number 14, they give us a circle with a radius of 9. They ask us for the area, it's just 9 squared pi, so 81 pi. They want the area of the sector. The sector is 120 degrees. This is one of those things that as you get familiar with this, you'll be okay with it, but 120 over 360 reduces to 1/3. So the area is simply 1/3 of 81, so 27 pi. When you get the circumference, you're gonna get 18 pi. 9 times 2 times pi is 18 pi, and so 1/3 of that is 6 pi. So what you'll notice with this would be 1/3, 120 over 360. This one, like for 1/6, would have been 60 degrees. If you get comfortable with those fractions, like 1/10 of a circle or 1/5 of a circle, you can simply multiply that 1/10 or that 1/5 times the circumference or times the area in order to find the measurements for that sector. Okay, hopefully that makes sense. So what I want to do now actually is we're going to go over to page 470. I'm going to take just a second and get rid of all of this because none of this do you need. If you do still need it, hey, hit pause and hit rewind, okay? So let's clear the board. I'm going to let you go to page 470 and read about lance, okay? So as I'm erasing, I want you reading about lance. You're reading about lance. Stop watching me. Okay, so welcome back. If you're still reading about lance, you can go ahead and pause it. When you're done, go ahead and play. What I'm going to do is I'm going to walk you through the first couple of questions together, just to make sure we're on the same page, and then I'll cut you loose, all right? So question number 1, is it true that all circles are similar? Yes. Okay. Can one circle be mapped onto another? Yes. Think about it. If you want to take any circle, they're all similar, right? If you want to take a little circle and make a big circle, you dilate it to make it bigger. If you want to take a big circle, make it smaller, you dilate it to make it smaller. Okay, that's it. That's it. Any circle can be mapped onto another by a translation and a dilation. Any circles. can be mapped onto each other from translation and dilation. That's all it takes. All right. So for number one, that's how it would take a translation and a dilation. Okay. And the answer is yes. Number two, they're wanting us to map, right? They're wanting us to map O onto P. Okay. Notice O ends up kind of in the middle there. So what we would need to do, the first step, I think, the easiest step would be to translate it first. How do we translate it? We're going to translate from O to P. So if you remember notation, capital T, yeah? And then we're going to go O, P, kind of like that. O is going to go to P, all right? That's telling us what's happening. We're translating O to P. We're going to do that first. Okay, so notice I kind of start on the right, put my parentheses out there, and then the next thing I'm going to do is I'm going to dilate it. How am I going to dilate it? Well, there's two things you need to know when you're notating dilation. You need to notate the center. The center of my dilation is going to be P, so I just put a P there. And then what's my scale factor? My scale factor is what would I multiply R by to get S. So what I would do is RK equals S, solve for my scale factor, S over R. And so that's what I write here. So this is what they're looking for number two. This is really good practice for you to get ready for the test, and also to remember to review transformation notation. So what this says is I'm going to take my circle centered at O. I'm going to translate the O over so that it becomes P, and then I'm going to dilate it such that the R becomes S, and that's going to make my new circle. Okay. Hopefully that makes sense. And then number three, it says what is the scale factor between circles? We've already solved that. So honestly, I don't know how you could do number two without doing number three, but whatever. So it says what transformations are performed. And I guess technically maybe it doesn't want the notation, but I think you should practice putting the notation. It also says if O is the prime is the image of circle O, identify the location of O prime is going to become P. All right. So I probably did a little extra there with two, but that's okay. It's good for you. So here's what I want you to do. You're going to do question number four. Question number four is on page 471. Sorry, struggling to talk today. So on page 471, you're going to do question number four. You're going to use this information, use what we talked about in the first couple of questions, and you're going to do number four, say 5 minutes, yeah? And then come back to me and we'll talk some more.